Hello, geometry students, and welcome to our continuing lesson on inductive reasoning. And here we're going to do some sample problems. We're going to look at a problem that asks us, describe a pattern in the numbers, write the next number in the pattern, and then graph the pattern on a number line. So in these examples, let's see, I am going to do numbers 5, 7, and 9. I will have you do 6 and 8. Okay? So you do 6 and 8 on your own. Alright, so now let's look at number 5. Let's see the patterns, if there exist maybe any patterns in these numbers. And we can look at some of them. And again, this is kind of hard to really show you, except to let you know what the idea of the pattern may be. So you might guess and check a little bit here and try to see if it makes sense. Okay. So here we have the leading digits 1, 1, 2, 2, 3, 3, 4, 4. So those are just the two leading digits. I can guess pretty much that the next digits are going to be, the next number is going to have the leading digits of 5, 5. Okay. And then the last digit increases, starts at 3, 4, 5, 6. And then the next one that I'm going to have is going to be 7. Okay. So that's probably going to be the next number here in the pattern. It says describe a pattern in the numbers. So I'm going to say the first two digits increase by 11. So if you take 11 and add 11 to it, you get 22. Add another 11, you get 33. Add another 11, you get 44. And then the last digit increases by 1. Okay. And I can graph this, and we're going to graph between 100 and about 600. So I'm going to start here at 0, 200, 400, 600. And it's perfectly okay to skip certain tick marks here. 113 is going to come around here. 224 is going to be right around here. 335, so this is 200, this is 400, so 300 is going to be in here. 446, so it's going to be between 400 and 500, and then 557 is going to be right about there. Okay, so that's what it's going to look like on the number line. Okay. Alright, well, like I said, I'm going to skip 6. I'll let you do that one on your own, and then I'm going to try and we'll do 7 together. Okay. So looking at this here, we have 1/3, 3/4, 5/5, 7 sixes. Okay. So we can make a number of guesses, but you can see here that the numerators are increasing by 2, and the denominators are increasing by 1. So I'm going to write that here. Numerators increase by 2. Denominators increase by 1. So if this first number increases by 2, you're going to have 9. And if the bottom number increases by 1, you're going to have 7. Okay. And then we are, of course, going to graph this. And you can see that many of these numbers are fractions. But this is, so I'm going to start here at 0. I'm going to say that this is 1, 2, 3, 4. So I'm going to say this is 1. Okay. And none of these numbers get up to 2. So 1, 0, I'm going to graph 3/4 first, because that's going to be the easiest. 1/4, 2/4, 3/4. So these are separated by 4. 5/5, that's just 1. That's the easiest ones to graph. 1/3 is going to be a little bit more than a quarter of the way. And then 7/6 is going to be a little bit in front of 1. And then 9/7, and if you use a calculator, it'll maybe help you a little bit more. It's going to be just past the 1 1/4 mark. Okay, so this is 0.5, that's this tick mark here, and then 1.5, that's this tick mark here. Okay? Alright, like I said, I'm going to let you do number 8 on your own, and I'm going to do number 9. Okay? So 9 here looks a little bit interesting. You can see that it increases by 3, and then by 5, and then by 7. Okay? And then the next one, it's probably going to increase by 9. It's probably going to give us 25. And I'm taking a guess here before I even write the pattern. But one thing that you can do, you can see here, is these are all perfect squares. Okay? So the pattern is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So these are numbers in the pattern are the squares of integers. Okay? So if I take 1 squared, I got this number. 2 squared, I get this number. 3 squared, I get 9. 4 squared, I get 16. 5 squared, I get 25. I'm going to graph this between 0 and 25. So let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers here. So I'm going to increment this by 2. I'm going to go maybe 0, 2, 4, 6, 8, 10, 12, 14, 16, 20, 24. Okay? And then I'll graph. Use a different colored pen here. Makes things a little bit easier. Number 1 is going to be right here. 4 is on the line. 9 is going to be just past 8. Then I have 16. Then just one more past 25, 24. That's going to be 25. Okay? And you can kind of see with some of these examples, you can see that as we go towards the right, the dots are getting farther and farther apart. Here in number 7, as we go towards the right, the dots actually get a little bit closer and closer. And maybe some of the other examples, you may or may not see a pattern. Okay. So we have a pretty cool pattern here. It says the first 3 objects in a pattern are shown. How many squares are in the next object? Okay. So I'm not going to do this one on purpose. I know it may be frustrating, but I want you to practice, even if it means you may struggle just a little bit here. So try this on your own. So I'll count the number of squares here. There's 1 square, 4 squares, and I'll let you see that go with the pattern from there. Okay, so how many squares are in the next object, and how many squares are in the 35th object? How many squares are going to be there? Okay. Finally, we get to some last problems here, and it gives us these statements, and we're asked to find a counterexample. In other words, we're trying to prove these statements wrong or disprove those statements. So it says the quotient of 2 whole numbers is a whole number. So we're trying to find a counterexample for this. So we need to find 2 whole numbers and whose quotient is not a whole number. So I can give, and there's many counterexamples here. Okay, one that I can think of is 7 and 2. Okay. So 7 divided by 2 is 3.5. So this is not a whole number. 3.5 is not a whole number. So there's my counterexample. The difference of the absolute value of 2 numbers is positive. I'm going to cross out this word meaning here and just go with that. The difference of the absolute value of 2 numbers is positive. So let's try a few possibilities. Okay, sometimes when these examples, if you don't know, you just take a little bit of a guess. The difference of the absolute value of 2 numbers is positive. So if you did like the absolute value of 8 minus the absolute value of negative 2, this is going to give you 8 minus positive 2, which is 6. So that works. Okay, that's not a counterexample. Since it meets the description, we want some examples that break the description. So let's try again. Absolute value of 8 minus absolute value of 10. Okay? So now we get 8 minus 10, which equals negative 2. So in this case, this breaks the statement. The counterexamples here are 8 and 10. Those are the counterexamples, not the final answer itself. Let's do number 17. If m is not equal to negative 1, then m over m plus 1 is less than 1. For example, if I did m over m plus 1, and if I say let m equal 5, then I'm going to get 5 over 5 plus 1, which is 5 over 6. That is less than 1. Okay? So this is not a counterexample. So let's see if you can think of maybe a number or two that may or may not satisfy this description. So I've thought of maybe try, m equals negative 4. Okay? So that means I have negative 4 over negative 4 plus 1, which is going to give me negative 4 over negative 3, which is equals to 4/3. Okay? 4/3 is bigger than 1. In other words, 4/3 is not smaller than 1. So this is a counterexample. Now again, 4/3 is not the counterexample. Negative 4 is the counterexample. It's the value that makes the statement false. Okay? So hopefully you get an idea of how to find counterexamples, and just thinking about special cases and special circumstances, because in geometry we're going to have to deal with that a lot. Somebody makes a statement, we don't know if it's true, so we have to try some weird and wacky scenarios to see if it's true or not. Okay? And again, I'm going to ask you to do 18 here on your own as well. So you have you take some notes here. We have a couple problems. We have 1, 2, 3, 4 problems here, and then 5 and 6 problems on the front. 2 more problems on the front. So that's a total of 6 problems to do tonight. And all I'm asking here is that you give it your best shot. If you get it, that's great. We can share with the class. If you don't get it, I will be happy to explain it with you tomorrow in class. So thank you for watching. As always, if you struggle, you should ask your teacher. Have a wonderful day.